Thank you for joining us. My name is Andy Hock. This is the MasterClass, The Future is Now. Not an unafraid title, right? We're in it. The past was just moments ago. The future, get ready for it, is right now. What we're going to talk about this morning, though, is the power of the right computing architecture to accelerate inference AI applications and the market. We're from a company called Cerebras Systems. We build a new class of chip and system to accelerate AI inference and training and really power the future of large-scale AI. So in this masterclass, I was joking earlier that I actually used to teach classes, but I've never actually taught a masterclass. So I hope you guys have filled out your prerequisites and visited the registrar to register. There will be a quiz at the end. The focus here is all on inference. And with me today and my co-presenter is my colleague, Angela Yeung. She's our VP of Product Management and the leader for our inference product development. So in this session, I'm going to introduce you a little bit to the principles and technology and product. And then I'm going to hand off the mic to Angela, and she's going to tell you a little bit about some of the really exciting real-world use cases and customer case studies where speed makes all the difference for their work. So let's talk a little bit first about the generative AI revolution, right? I think if you're in this room, you probably already believe that AI has transformative potential. And if we reflect back maybe half a dozen, 10 years, much of the focus in AI computing was in training. And indeed, training is still a foundation of the AI compute market, and it's growing. But particularly over the past several years, teams and companies have built new AI foundation models that are powering revenue and efficiency in business. And as a result, those models that people were building are flipping into production, right? And that's where generative AI inference makes all the difference. So we see people building generative AI apps for everything from language-based chatbots to forecasting time series for things like preventative maintenance, for voice assistants, drug discovery, and fundamental physics and material design, right? So there's a huge range of transformative applications that aren't just relevant to, say, idiosyncratic research problems, but that are relevant to the mainstays of our economy. So then let's talk a little bit, that's really exciting, right? That's cool. But let's talk a little bit then about some of the challenges, right? One of the challenges is speed. I would say that proverbially, today we are in the dial-up era of generative AI inference. Now, some of you in the audience, I won't say which, and others of you in the audience, you may or may not remember what modems sound like and what it really means to be in the dial-up era, right? But in the dial-up era, for those of us that remember, what it meant was waiting, right? It meant latency. Not only did it take a long time to establish a connection, but if I wanted to do a Google search, it literally took minutes for an image to read out row by row of pixels, right? And then you ask yourself, okay, well, we're not in that era anymore. Some of us don't even know what the modem sounds like. What difference has speed made? And it turns out that speed in the internet era, just like the Gen AI era, speed doesn't just mean the same applications get faster, right? Speed in internet search didn't just mean that bulletin boards got faster, right? It didn't just mean that Google search got faster. What it meant and what it implied was the creation of new $10 to $100 billion industries. Speed not only made things like Google search more sticky, more interactive, but speed also opened the door to things like social media, streaming media, all the things that we all used probably a dozen times before we even set foot in this room. So speed doesn't just make the same applications faster, speed opens the door to new markets. So let's then shift a little bit to the specifics of generative AI and why speed is a challenge still for legacy general purpose processors in generative AI. Right? Many of you may have experimented with simple inference chatbots like GPT-4o, right? Where one question from me results in one test time computation or one computation of the inference model, and I get an answer back, right? And those are already really powerful, right? They're already driving new efficiencies and revenues in enterprise. But as many of you have maybe also heard, right, there's an emergent class of new models called reasoning models. And then people are also building AI models that are actually composed of many smaller or daughter AI models called agents, right? Both of those, as you can see here, a simple inference model like GPT-4o, right? One query is effectively one computation. So we'll just talk the bottom row there, the X factor is, think of it as computation X factor. With a chain of thought or reasoning model like OpenAI's O1, right? One question from me might result in 10 computations as the model cycles through itself multiple times to reason. And when we start using reasoning models combined with agents, the computation requirement for inference starts to grow logarithmically, right? And so one challenge of generative AI inference computing is that the world of generative AI in the future isn't going to be composed exclusively of simple inference models. We're going to be working in a world where reasoning is a standard, where agentic workflows are a standard, and the computation requirements for those are much larger than what we're seeing even today. Even some of the leaders in industry that build traditional general purpose processors like GPUs, Jensen Huang here says, we need bigger chips, right? And one of the reasons why he's saying we need bigger chips is because the inference compute requirements are so large, right? We need more computation. But it's interesting that he didn't say we need many more tiny chips, right? What he actually said is we need bigger chips. And the reason for that will become apparent in a second. And it's fundamentally that AI computation wants not just a lot of compute, but it also wants a lot of memory bandwidth and communication bandwidth, because all of these problems, whether it's training or inference, are handling data in motion, right? And large chips can handle massive computation plus data in motion far better than clusters of many tiny chips. So in order to go up this ramp, say from instant AI to advanced reasoning to automated agents that can operate in the real world to frontier AI, right? We need not just more of the same kind of compute, but a fundamentally different kind of compute. And we happen to think that Jensen was right. It needs to be a bigger chip. That's where we come into play. Our company is Cerebras. You may already be familiar. We are an AI chip systems and solutions company. We're based out of Sunnyvale, California. We've built, as I said before, a fundamentally new type of chip and system to accelerate AI training and inference by orders of magnitude beyond general purpose chips, and really be that platform for the future of frontier AI. We're not only in Silicon Valley, we're also in San Diego, Toronto, and Tokyo. We have extraordinary investors from Silicon Valley and beyond, including Benchmark, Foundation, Eclipse, as well as leaders in industry like Qualcomm, TSMC, and more. I often joke that most great hardware companies are actually mostly software engineers. That's true at Cerebras as well. We're about 500 employees. About a third of that is on the hardware side. We design chips, we design boards, we build and we integrate computer systems, we put them into data centers. Our software team is about 2/3 of our population because, of course, once you build a radical, powerful new computing system, software is how people use it, right? So you need to invest significantly in making that new computing system easy to program with simple standard frameworks that the developer community uses today. So you can program our system with PyTorch or program against a simple OpenAI schema API, right? So we're a lot software engineers, and then we also have an extraordinary team of ML and AI researchers that both do first-party research and also partner with our customers to help them build new state-of-the-art models and deploy them at breakneck speeds in inference. And we have a growing and extraordinary list of customers, and you're going to hear some more about those specifically on the inference from Angela in just a few slides. So when I mentioned we had a different chip, it's actually quite different. This is the heart of our technology and our product innovation at Cerebras. It's called the Cerebras Wafer-scale engine. It is the world's largest computer chip by more than a factor of 50 compared to the next largest before it. And it's a pretty impressive device, genuinely. Industry has been working at so-called wafer-scale integration for a couple of decades. But the reason that we did this isn't just because it looks cool and it's hard. It's because, as Jensen said in the last slide, big chips are actually better for AI. So on this single chip, we have 900,000 compute cores. Not only do we have all that compute, so think of it as a cluster worth of AI compute on a single chip, but all that compute is interconnected over silicon, and it all has on-chip local memory. And that unlocks a fundamentally new performance paradigm for both training and inference. To illustrate this, I'll illustrate one of the challenges of generative AI inference computation on GPUs. Before we get specifically to the GPU architecture, let's talk a little bit about what generative AI inference computation looks like and why it's actually just hard in principle for any processor. The fundamental reason here is, let's say I have an 80-layer model, an 80-layer neural network, and I want to run, and it's a generative AI inference model. For every new word or every new token that model predicts, it's got to run the whole model. So in this example, in order to produce a sentence, say, that says, the quick brown fox jumps over, for every new word, I have to compute the entire model, right? And so there's a massive amount of computation. And then you start thinking about, well, hey, maybe I used ChatGPT this morning or Gemini this morning, and it produced, a couple of pages or paragraphs, right? So there's a ton of computation going on underneath the hood. But where this gets extraordinarily difficult for traditional processors like GPUs is that for each one of those computations, for each one of those layers that it has to grab of the model to compute, a traditional chip actually has to read each and every layer back and forth from not on-chip memory, but memory that's on the same package, but separated by a wire, right? It has to read from HBM memory. And so every time I compute a token, say through this 80-layer model, I've got to grab and then write back, grab, write back, grab, write back. Every single layer of that model, back and forth over a fairly narrow cable, right? So a modern GPU like an H100 from NVIDIA has something like 3 terabytes per second of memory bandwidth. That is the thickness of the pipe between HBM memory and the compute chip that's doing all the computation. And it's the slow off-chip interconnect that makes generative AI inference on a traditional chip so hard. When we look at our chip has, again, 900,000 cores, but for generative AI inference, the chip is working exclusively from on-chip memory, right? So whereas the GPU's performance for generative AI inference is bottlenecked by memory bandwidth, because it's got about 3 terabytes per second, we have literally 7,000 times more memory bandwidth available to us on the wafer-scale engine. It doesn't mean that our chip is without bottlenecks for this problem, right? It just means it's a different bottleneck. For us, we need more compute, right? We'll start to run into performance bottlenecks with compute. But because we have a fundamentally different amount of memory bandwidth, we can unlock truly remarkable levels of performance that no number of GPUs can deliver. This is what that looks like in practice. I'm going to step aside from the fern. So if you look down at the bottom of this chart, you'll see models like Claude Sonnet, GPT-4o, Gemini 2.0 Flash. And the speed metric here is output tokens per second, right? That means once you write in a query, how fast do the words spill out of the model? So faster is better, as we know from Google search and from decades in industry. All those speeds are typical speeds from different GPU providers. And they start to run into a wall, right? Even the best GPU engineers on the planet, even the best model builders on the planet will only reach a certain level of performance with GPU infrastructure under the hood because of that fundamental architectural limitation of GPUs and the memory bandwidth. That's what we've depicted there as the little brick wall, the GPU HBM wall in output speed. On our system, indicated by the orange bars up top, we're powering, as we announced recently, Mistral's LeChat model and Perplexity's AI Search Pro Sonar model. And you can see there that we're literally delivering output speeds that are not only faster than any GPU on the planet, but they're faster by a lot. I'm not just cherry picking examples, and it's not just those two models. Literally every single generative AI model that we test and deploy on our system is orders of magnitude faster than any GPU solution on the planet. So this chart shows, this is actually data not from us. You don't have to believe us, right? This is data from Artificial Analysis, which is a private third-party firm that just hits various providers' APIs and then measures the speed of the tokens coming out. Right? And what you can see in all these examples, this is Llama 7dB, Llama 405B, and DeepSeek R170B. The orange columns at the left are us. Speed is higher as you go up. And the comparisons there are to not just the world's best hyperscalers like Amazon and Microsoft, but also teams like Fireworks and Together AI that have built teams and clouds around extracting every bit of performance possible out of GPUs. And these charts also include some of the other novel AI chip architectures like Samanova and Grok. So across the board, we're the fastest. So here, that's where I've shown you, I think, enough data and I've set the stage. But you might be asking yourself now, well, Andy, that's cool. Numbers are great. But how does this really matter for application developers or enterprises? What are some of the concrete use cases where speed really makes a difference? And for that, I'm going to hand off the baton to my colleague and partner in crime, Angela. Over to you.
Thank you, Andy. Hey, everyone. My name is Angela Yeung. I'm VP of Product here at Cerebras. And today, I'm very excited to show you some of the applications that are actually using Cerebras inference. So you can see the impact of fast inference in the real world. So let's start with Perplexity. Who here has heard of Perplexity? It's most of us. One of the most popular AI applications right now for search. And Perplexity trained their own model that was based off of Llama 7dB. And combined with running that model on Cerebras hardware, they were actually able to demonstrate higher user engagement metrics compared to the default model that they'd been using before. So I'm going to show you a video of what this actually looks like in practice. On the left-hand side, you will see, actually on your right-hand side, you will see Perplexity powered by Cerebras. And on this side, you will see ChatGPT. So let's roll the video. So that's Perplexity. That's already done. 1,200 tokens per second. And ChatGPT is just getting started. Let's look at another example. This is Mistral AI. Mistral is one of the top foundation model builders today. They recently launched LeChat in France, currently the #1 chat application in France with over 1 million downloads. And Mistral partnered with Cerebras to create a feature called Flash Answers, which delivers faster answers to their users. Now, what are some reasons why users actually care about fast answers? Now, imagine you are a developer and the core of your job is actually writing code. If you can write code faster and have more iterations, then you're that much more productive. So let's look at how Mistral AI can actually write for you a snake game in Python. So that's Snake and Python by Mistral's Le Chat, already finished. And ChatGPT just getting started. So you just looked at two cases of where fast inference really matters for chat applications. And we all use chat applications every day. But that's not all. We at Cerebras believe that fast inference will actually unlock brand new applications, including instant and intuitive conversational AI, smarter search that can actually proactively predict what you want before you even search for it, and deeper reasoning in less time. So let's take a look at how some of these applications are being shaped in the market. So we've all used the phone and found that it's going to be picked up by a robot and it says, press 1 for customer support, press 2 for a different language. And that's really frustrating, right? Not a good experience for anyone. OpenCall is trying to change this. It's an AI-powered call center, but it's fast and intuitive, and it's powered by Cerebras. So I'm going to play a video of what an AI-based call center sounds like. I want you to actually close your eyes for this video. The video is a little out of sync with the audio, but you don't need the video at all. So just close your eyes and listen.
It's Vegas. Can I help you book a ride?
Yeah, I was looking to book a ride.
Let's get you booked. Where would you like to be picked up from?
Yeah, the Sphere,
Got it. And where should we drop you off?
the Bellagio.
I'm putting that into our system. Will this be a round trip?
No, just one way.
Got it. How many people are in your group?
We have 8 people.
I'm creating the ride now. Just one moment, please.
Yeah, no, that's fine.
I've created a booking link for your one-way trip from 2555 Sands Avenue to 3600 South Las Vegas Boulevard. I'm sending you the link to complete the booking now via text. Is there anything else I can help you with today?
So that's instant AI, conversational AI powered by Cerebras, zero latency. And what OpenCall actually found after launching with Cerebras was 90% lower latency for their users, resulting in 20% higher customer satisfaction. So fast inference is really making an impact to businesses and allowing businesses to derive more value out of AI. Taco is another great company working with Cerebras. You saw a couple examples of how Cerebras can power instant search. Taco is taking this one step further. Not only are they using Cerebras for search, they are actually generating information cards on the fly for users instantly based on what they predict that their users will be interested in. So let's hear from the founder and CEO of Taco.
Why search at all? What if Taco could proactively pitch you related knowledge cards wherever you research and author content without you having to form a question? Hi, I'm Alex Rosenberg, CEO of Taco. Taco is a search engine for visualizing and sharing the world's knowledge. Apps that rely exclusively on large language models in the open web hallucinate, are out of date, and miss out on the most important authoritative data that's not readily crawlable. Taco is transforming research and productivity by grounding analysis and storytelling in real-time, authoritative data presentations called knowledge cards. We take the world's most credible sources and make it frictionless to search and generate customizable knowledge cards from them. Developers use Taco to build rich, interactive, and visual AI-native products. Our customers serve consumer search and productivity use cases where latency is measured in milliseconds. Taco leverages large language models in its natural language processing pipeline to take language and translate it to our proprietary structured query format. Let me show you an example. When a user asks, how much does China spend on its military? Taco knows to return a time series knowledge card sourced from the Stockholm International Peace Research Institute. We don't want to sacrifice speed for quality, so we need extremely fast inference to deliver Taco. That's where Cerebras comes in. We leverage Cerebras' Llama 3.37b to help us answer customers' questions with accurate, real-time knowledge cards almost as fast as they ask them. Since integrating Cerebras, we've seen our median and P95 search latency reduced by 60%. This hasn't just made our core search product experience better, speed unlocks entirely new use cases. For example, we asked ourselves, why search at all? What if Taco could proactively pitch you related knowledge cards wherever you research and author content without you having to form a question? For our related search feature, AI content creators pass us entire articles, presentations, and other long-form prompts, and we return contextually relevant related knowledge. Let's say you want to write an essay comparing Uber and Lyft since 2020. Taco takes your essay and returns Uber and Lyft stock price charts while your essay generates. Traditional GPU-based inference was far too slow and cost prohibitive to meet user expectations. With Cerebras, we are able to generate knowledge cars at scale with the large amount of data our users now send us without sacrificing user experience. Cerebras has truly elevated the Taco experience, enabling speed and ideal answers delivered through compelling visuals. At Taco, we're excited to keep pushing the boundaries of what's possible in search.
So we're very excited to partner with Taco and to see the incredible breaking, cutting-edge applications that they're doing in AI. Now, many of you have heard of reasoning and DeepSeek, and reasoning is actually a fantastic application for fast inference as well. When DeepSeek came out with a reasoning model a couple of months ago, this model basically allowed for in-depth, thoughtful answers, oftentimes hundreds or thousands of tokens generated before getting to the final answer. Now, Cerebras was able to take the DeepSeek Llama 70B distilled model and generate tokens at 1,800 tokens per second. What can we do with this? Well, later today, or tomorrow actually, we are announcing a partnership with AlphaSense, which is a business intelligence platform for finance services. And AlphaSense is now using this DeepSeek model powered by Cerebras to generate answers for their users who come to them every single day for real-time insights on the financial industry. How can you get started with Cerebras? Well, it's very easy. It takes less than 30 seconds to get a Cerebras API key and switch over from whichever inference service you are using to Cerebras. Andy and I will be here after the talk, so if you're interested in getting an API key, come out and come find us. In addition to a serverless API, we also offer on-premise deployments. Cerebras is a hardware company at our core, and so if you have your own data centers, or if data sovereignty and data governance is extremely important to you, we can work with you to deploy an on-premise Cerebras solution in your data center. And finally, if you are concerned about capacity, never fear. Because of the huge demand that we're seeing for Cerebras inference, we have invested in data centers all across the world coming online from Q2 through end of this year. And we will be serving more than 40 million tokens per second of Llama 70B by end of this year. Tomorrow, we're announcing a partnership with Hugging Face. This one's a little bit of a preview, so I'll ask you to keep this information to yourselves for the next 24 hours or so. But Cerebras is very invested in making sure that as many developers as possible can gain access to Cerebras inference. Hugging Face is one of the most popular communities for developers, and we are now making Cerebras inference available to all of their developers instantly. So Cerebras does more than just inference. We have trained dozens of state-of-the-art models on our platform. And although the talk today was focused primarily on inference, please come find myself and Andy afterwards if you're interested in learning more about our training platform as well. No other platform is as productive as Cerebras when it comes to training state-of-the-art models. One last slide. Feel free to take a photo of this one with a summary of everything that Cerebras does, from inference to training, and also high-performance computing, which we didn't cover today. And that's it. We'd love to see you tonight at our VIP reception. There's a QR code up there. Try our serverless API, and we will open it up for questions.
Any questions? We probably have time for, how much time do we have, team? 10? Okay, questions?
How is training Cerebras using the CUDA cores, or how do you utilize that in your software stack?
No problem. I'll give you that. Yeah, so thanks for the question. The question was, how do we do training? The answer is it's actually exactly the same hardware under the hood. It's that same big chip in the system. NVIDIA's GPUs have something called CUDA cores. This is a fundamentally different architecture, right? So it's not just a bunch of GPUs stitched together. We use our cores on this device to do all of the training that Angela mentioned. And as you could see, the performance advantage at inference, right? Order of magnitude faster performance for computation. Fundamentally, the same is true for training, right? That is, if you want to train a model, whether you're fine-tuning a model or training a model from scratch, and whether you're working in language or some other type of structured data, let's say like genomic data, which we have a lot of customers doing for drug discovery, you can train models on our system, say in hours or days on one of our systems, compared to say days or weeks on competitive GPU clusters. So it's fundamentally the same hardware under the hood. It's the cores on this big wafer-scale engine. And it's some of those same architectural benefits, the many cores, high memory bandwidth, high communication bandwidth, that allow our system to be not only faster, but easier to program for large model training. And we're happy to go into detail on that maybe in another MasterClass in the future.
Okay, I wanted to just say, if you guys do want to attend our VIP reception, we are completely sold out. So you're going to have to put the code MasterClass to try to get off the list. So I just wanted to say that. If you want to come, you need to use the code MasterClass. Okay, next question.
So the examples that you showed had, incredible speed. Is there any limitation in use cases in terms of the amount of input tokens, using RAG or output? Are there better uses for this hardware or worse?
So our biggest differentiator is our output speed, which you saw, but we are actually also faster on prompt processing speed. So typically what we see with our customers is they plug in Cerebras for the LLM inference, and if they also have a RAG pipeline or other services that they're calling, they just use that alongside Cerebras.
But there is also an advantage on the input with
There
RAG.
is, correct.
Thank you.
Yeah, that's a great question. At the end of the day, everyone wants to know what the cost and total throughput they'll get, especially if they're interested in an on-premise style deployment. The way I think about it is Cerebras is optimized for latency. That's what we care about the most. We believe that high performance inference will unlock all of these new applications for AI. And when we are in that latency optimized regime, we are also the most concurrent in that regime. So if you care about latency optimized, you can get very high concurrency through Cerebras and generate higher tokens per second total throughput compared to a similarly latency optimized NVIDIA, which actually won't be as fast. It'll be still 20 times slower and generate fewer tokens per second in total throughput. Now, NVIDIA also has the ability to do a throughput optimized regime where you could have very, very, very slow numbers of output tokens generated per second, and they can scale up throughput that way. But when you care about latency, Cerebras is the winner.
I'd love to understand a little bit more about memory and what memory means. Does that mean context around a specific user and who they are and their background, what they've done, or does it mean different things?
Sure. Let me just clarify your question. So when you say memory, are you thinking about the context that gets put into a model? Yeah, absolutely. It's very related. So memory is one of the most important abilities of AI, actually, to basically take in a certain amount of what is typically called context or information and generate an answer based on that information. And one of the great unsolved problems of AI right now is actually we haven't really solved the memory problem, right? As humans, we take in so much information. It couldn't possibly fit in any chip, even the size of the one that we have here. And so there's a lot of work ongoing to figure out how to help AI have better memory to, for example, identify the most important memories within a larger amount of data. And all of that, I think Cerebras will play a central role in that because of how much memory we have on our chip and how much we're able to continue to optimize based on that.
Yeah, I was just going to chime in really quick. Yeah, so over the past couple of days, there's been a lot of hype around large language diffusion models in terms of their speed, et cetera, and ability to use significantly less tokens. Have you guys thought about how that's going to factor into your roadmap?
Yeah, great question. We've actually started looking quite a bit at image diffusion models. We are still looking at some of the language diffusion models and taking a look at what the impact will be there in terms of quality. But I think the architectures of models are developing very quickly. And what's very exciting about the space right now in AI infrastructure is just how quickly the model architectures are developing and how much that actually has to do with the hardware itself. And one of the reasons why models develop is actually to further optimize on the hardware. So we'll certainly be tracking those changes very closely.
Okay, I just wanted to thank everybody for joining us at our first ever masterclass. You guys were amazing. And let's see, one last shout out. You know, you saw some examples up here. Some of our adopters are really the brightest startups in the world. They're very brave. They're very innovative. They want the fastest tokens. And we have our startup program leaders in the back, Daniel and Isaac. They are here at HumanX, just flew in. If you're a startup and want the super fast tokens, please reach out to those guys. Okay, thanks a lot.